Hey, everybody, this is Larry. This is day 6 of the June Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem. Let's see, what's today? Intersection of two linked lists. That's funny because the contest we just had was, the Q4 was a solution was supposed to be a double linked list, though apparently the brute force / naive solution kind of worked, so we'll see how that goes. But it is something that comes up from time to time on interviews, so definitely something to think about. Yeah, let me double shoot. Okay, just want to double check that I'm recording the right screen, because as my long-time viewers know that happens from time to time. All right, let's see, what's the problem? Problem is, given A and B, return the node in which the two lists intersect. Okay. So we just return the node? Yeah, okay. The first thing I would do is just look at the constraints, because you can definitely do for m, for n type things very quickly. And then the other thing you can do is just, having a lookup table, right? That's just standard lookup stuff. I'm trying to think whether you could be a little bit smarter. In theory, you can do some sort of binary search, but I don't think that actually, because of the cost function, is going to be linear in this case. I don't think it actually makes it that much faster, at least without using extra space. So, no, m plus n in all of one memory, huh? Can I do this? I mean, yeah, like the reason why this is easy is because I think anyway, you're supposed to do it with that lookup hash table lookup thing, and that would be pretty standard and pretty simple. But I'm trying to see what I can do it all of one memory. Of course, all of one memory is a little bit trickier. Also, always feels like these are kind of things that are always a little bit silly. Like there's always some like really weird one-off solution that I try not to think of, remember, because one-off solutions aren't that interesting to me. But yeah, let's see. Can I do this in a smart way? I guess the smart way is taking the length, right? And what do I mean? Meaning that given the length of these things, yeah, that means that you would do an offset on B or A. So okay, I think I have the idea now. Though it's a little bit weird, but I think the idea that I was trying to think about, and this is something that I always say with linked list problems, is that it doesn't come up that much in competitive programming. So I definitely is a bit rusty about it. So the techniques sometimes I am going to have to solve it live. And as I always say, everything in this video I solve live. I don't really cut away, and that's sometimes I cut away because I have to turn off my Alexa or something, and I'm talking to Alexa. But otherwise, I don't really cut. Even then, I don't cut away. I just mute myself for a second. I don't really cut away because I want people to see how I solve these problems live and with all the difficulties that may entail. But this one, I feel like the thing that I would immediately see is that here, and they kind of did us a favor in drawing it out, and I think that's where I have this idea. Maybe in theory, I should have drew it out on my own, notepad and stuff like this, and pencil. But I think looking at here, it means that if we were to intersect, right, that means that the earliest that could intersect, in this case, is of course the first item, right? Meaning that, or the item after the first, because let's say B has 6 items in this case, and A has 5 items, right? That means that B has to have the same length for them to match up. And you could kind of do this maybe inductively with respect to the last element, right? If the last element of if the last element of B matches up, what do the thing have to look like, right? And if the second last and so forth, and they all generally have the same shape, which is similar to this example one that I'm highlighting now without a loss of generality, because of course you can always swap A, B if A is longer or something like this, right? And in this case, yeah, so I think the thing is just to get the length of A, get the length of B, and then start A off with that offset, and then just keep on comparing. I think that should be a good attempt. So yeah, let's get that. Let's have a function that gets a length from here. So yeah, so then len A is equal to get length of head A, len B is equal to get length of head B, right? Then here is count is equal to 0. Maybe it goes to 1, but while node is not none, count increment by 1, node is equal to node.next, and then return count, right? Let's get length, standard linked list stuff. And then now we have a how do I do this? Okay, so if length, let's just make sure that length A is the smaller one, just for whatever. So if length is greater than B, then length A, we want to swap them. Oops, that's not swapping. That's a no-op, or worse than a no-op, I guess. So we swap, and then now we know that length A is less than length B. So then now delta is equal to length B minus length A. Whoops. And then now current A is equal to head A, and then we move it up delta times. And then now we can do while current A is not equal to current B, and I have to set current B is equal to head B. Then current A is equal to current A dot next, current B is equal to current B dot next. And in theory, my guess is that when they're both none, then they would equal to each other, so then we could just return none, right? So then now I think this should be good, but this is why we test. Just give it a spin. Oh, typo. This is why I don't YOLO submit, because I always have to do things like this. Huh. Oh, no, wait. That doesn't make sense. They should be both be none together, right? And this is me just not knowing what Python does in this situation. I generally don't try. I try to not, if they're both none, then I shouldn't do it. But that's weird. Where is it debugging? Where is it bugging out? So current A is equal to this before it crashes. Did I screw something up? Oh, I messed up. Okay, that's why. I said that A is less than B, so we have to move B, right? Not A. Whoopsie daisies. Okay. I guess we could just change this as well. The other way. Because I kind of wrote the code wrong for the wrong one. But the idea is the same, it's just that I kind of mixed them up. Okay, still wrong though. So A is greater than B, we move to delta. Oh, okay, whoops. Wow, I am very sloppy today, as you can see, but the idea hopefully is still right. That's what I mean by me saying recently that my implementation is a little bit off. I think in algorithm, like problem solving, I want to say I'm mostly on point, but my solution's been a little bit bad. So anyway, let's give it some minute. Let's see how that goes. And this looks good. And yeah, this is going to be O of m times n as we want from the follow-up, and O of 1 space, because we look at each linked list. It'll be linear time, so this is m plus n. And here it's just going through the list one more time. So it's going to be another m plus n. So m plus n together. And as you can see, this is all just single variable, no recursion, anything. So this is going to be all of one space. So yeah, that's pretty much all I have for this one. Let's see what I did last year or whatever. Okay, so I did the same. No, did I? Oh, wow, I did this. I'm not a fan of this, but okay, fine. I did this hacky thing of, I'm not even going to explain it. If you want to check out that video, check it out. But it's just like using a hash table in a quite crappier way. So I don't know how I feel about it. Cool. That's all I have for this one. Let me know what you think. Stay good, stay healthy, to good mental health. I'll see you later and take care. Bye-bye.